In a previous video, you saw how we can start to poke around inside our models by accessing the different layers in the model and the weights of those layers. In this video, we're going to take it a step further by accessing different layers in an existing model and using those layer outputs to build new models. This is where it's really useful to understand about tensors and variables in TensorFlow. Remember that the variables store values, like model parameters, that persist during the program but can also be changed during the program. Tensors are what are passed around in the computational graph. They represent the inputs and the outputs to the various computational blocks inside the model. And it turns out that we can easily access these tensors inside a network and use them to build new models out of old ones. Let's see how it works. Here's the same model we were using in the previous video. It's a simple convolutional network that we've built using the functional API. Remember that with this method of building models, we use the model class and pass in an input tensor and an output tensor. We have those available from the way that we defined the layers. Remember that we're instantiating each layer object and then calling that layer object on a tensor input, and it then returns a tensor output. We feed that tensor output as the tensor input to the next layer, and so on. Once we have the model built, we can access those input and output tensors directly from the model object itself. And this might look a bit familiar. We saw earlier on in this week how we can access a model's input and output tensors with the input and output attributes. And the same is true for each of the layers as well. So here, I'm retrieving the convolutional layer by name, and then retrieving the input and the output tensors using the input attribute and the output attribute. If I print them out, we can see that these are tensors as we expected. And also, it makes sense that the input tensor to this layer is the same as the output tensor from the previous layer. Now here's where it gets interesting. Every layer has an input and output tensor, and every model has an input and output tensor. As I said, with the functional API, we are constructing models by passing in the input tensor and output tensor to the corresponding keyword arguments. That means that we can build new models using tensors that we can access from inside other models. Here's an example. I've retrieved the output tensor from the flatten layer in our existing model. I can then build a new model, I'm calling it model 2, which uses the same input as our original model. You see here I'm passing in the model input tensor. But the output of this new model is now the output of the flatten layer. So what we've essentially done is just to remove that final dense layer from our model. Let's take this a step further. We can also take parts of an existing model, use them in a new model, but add extra new layers in this new model. If you've seen transfer learning applications, then this kind of idea will probably look familiar to you. As we've just seen, Model 2 only uses the first few layers of our original model, without the final dense layer. And here I've created another model, Model 3, using the sequential API. So the sequential API allows us to include an entire model as one of the items in the list that we pass into the constructor. So then Model 3 uses the same first few layers as our original model, but with the final dense layer removed, and adds a new dense layer on top. Of course, we could also do this with the functional API. Here, we're creating a new output tensor by instantiating a new dense layer object and calling that on the output of Model 2. Then Model 3 is built with the model class by using the input tensor from Model 2 and specifying the new output tensor as the model output. In fact, with the functional API, it's not necessary to build the intermediate Model 2 at all. Here is the same final Model 3, which only works directly from our original model. The new dense layer takes in the flatten layer output tensor as its input and produces a new output tensor. We can create Model 3 by directly using the original model input and the new output tensor. Now we're really starting to increase our understanding and the possibilities of what we can do with deep learning models in TensorFlow. Hopefully you have a good feel now for how tensors and variables are used in models, and how you can access them and manipulate them to create sophisticated and customized models for your application. In the next coding tutorial, Nassim will show you a really nice demonstration of how we can use these tools with a pre-trained network. So have fun playing around with that, and I'll see you in the next lecture video.